We've started.
Hello, and welcome to this breakout session. My name is Ivan.
And I'm Connor, and today we're super excited to share Windows Inbox models and Windows AI APIs with you. Let's start with some common themes and pain points we see from our commercial customers. Since 2022, the exciting AI paradigm shift has benefited organizations that can use cloud AI the most. But there are many segments of the commercial market that can't just use cloud AI for regulatory, compliance, internet, or user experience reasons. We think local AI has the potential to fill many of those gaps. AI has become an essential part of modern applications, but running models only in the cloud isn't always optimal. With model sizes getting smaller and smaller and more efficient hardware, creating local AI experiences today is more possible than ever. With power-efficient neural processing units, or NPUs, like those found in Copilot+ PCs, models can now run proactively or constantly in the background, creating a whole new class of user experiences. We're seeing many developers and enterprises leveraging local on-device AI capabilities in Windows for a few key reasons. First, the compliance landscape is evolving. Regulations like DMA, GDPR, and HIPAA pose specific requirements on data handling, and local model execution enables full control over user data, as the greatest security is never having data leave the device in the first place. Second, performance is paramount. Certain user experiences are only viable without the addition of network latency, and local model execution makes those possible. Additionally, not all deployments have reliable internet access, and they must function independently for high availability. Third, certain workloads like audio, video, or input processing, running models right on the device provides meaningful benefits. And lastly, not all models need cloud scale, and running them locally can optimize costs without cloud calls and improve user experience. To demonstrate the value of local AI in Windows with Windows AI APIs, let's watch a video from our friends at Vista. Their app, powered by Windows AI APIs, allows low-vision healthcare workers to deliver in-field healthcare visits in rural India. Let's take a look.
Sundarbans, the heart of Earth's most expansive delta, nurtures the largest mangrove forest on the planet. This isolated, fragile geography is only accessible by waterways. But for most, a dangerous boat ride is the only link to healthcare.
Ecologically fragile, world's largest delta, Sundarban Islands, has the highest rate of blindness in India, double the national average of 1 in 100. This population suffers from extreme poverty and has no access to even basic healthcare.
And yet, in this remoteness, a new light emerges. Visually impaired community health workers make healthcare accessible to the underserved Sundarbans community. The DotPad is an innovative multi-line tactile digital braille device that enables visually impaired individuals to access information. A simple training session led by the innovators of the technology is all that it took to empower the visually impaired persons, Oshit and Tumpa.
With Vista on Windows, blind healthcare workers can now be hired to provide healthcare services and community education in highly isolated environments like the Sundarbans, using DotPad and Microsoft Surface Copilot+ PC. Thanks to Windows ML and Windows AI APIs, educational materials can now be summarized into visual braille, which can be easily consumed via hands-free voice navigation.
Our vision is to integrate accessibility into every breakthrough, creating opportunities that extend far beyond the Sundarbans. With Vista, using on-device AI technologies, including Windows AI APIs and Windows ML from Microsoft, we demonstrate that massive amount of visual and text content on PowerPoint slides can be summarized in text and braille easily, making it possible for blind healthcare workers to be employed to deliver healthcare educational materials to underserved population in East India. By partnering with Microsoft and FIH, we are committed to driving more AI-powered innovations and greater societal impact globally in accessibility, employment, and healthcare for all.
our nonprofit, Foundation for Innovations in Health, has been delivering primary healthcare services to the island population for the last 10 years. Through our partnership with Dot'in and Microsoft, we now have an innovative answer, Vista.
From the eyes that are unable to see, a vision shapes the future, guiding the community towards health and hope.
I find it truly inspiring how Windows AI APIs help visually impaired people interact with digital content and navigate the documents. At the same time, sighted users benefit from the same AI components to improve their productivity. It's a perfect example of Microsoft's mission. These Windows AI APIs really empower every person on the planet to achieve more.
If you were following along with us at this year's build, we introduced Microsoft Foundry on Windows, an evolution of Windows AI Foundry. This is a unified, secure platform supporting the full AI developer lifecycle, from model selection, fine-tuning, customization, all the way to deployment, while enabling execution across GPU, NPU, and CPU. The fastest and easiest way to integrate local AI into your Windows applications is through Windows Inbox models and Windows AI APIs. Ivan, can you tell us more about the models we ship in Windows?
Definitely. The Inbox models on Copilot Plus PCs are deeply optimized for the NPU in several ways. First, we apply quantization to shrink their disk footprint and reduce memory usage. Second, we tailor device-specific optimizations for each hardware vendor, ensuring low latency, high performance, and energy efficiency. What's great is these models are automatically downloaded to the user's PC, they are shared across the system, and are available to multiple apps. This means developers don't need to worry about resource consumption or deployment overhead. It's all handled for you by Windows. And of course, every generative model that we ship is safety aligned and meets industry-leading quality standards.
Thanks, Ivan. So what I'm hearing is the models are optimized for your device, they have a small footprint, they're battery efficient, they're always up to date, and they're shared across the system for all apps to use.
Exactly.
That's pretty awesome. Everything in the purple box here runs on Copilot Plus PCs, powered by the Neural Processing Unit, which is a power-efficient chip good at AI inferencing. As a result, your CPU and GPU on your PC are freed up for other tasks, leading to better battery life and overall PC performance. Whether you're working with text, documents, or images, these APIs can give you the right building blocks for your AI tasks. Our natural language APIs, including generic prompting, utilize PhiSilica. We also provide text intelligence APIs for things like summarization, rewriting, and converting text to table. Our vision APIs include imaging capabilities like image and video super resolution, image segmentation, object removal, and image description.
And just to add, Image Description API takes visual input and produces the description of the image in natural language. As such, it's also built on top of PhiSilica, our foundational model. Connor, by the way, Vista did use Image Description API in their demo, right?
That's right, and they're also using the Summarization API, as well as our Text Recognizer API, which is powered by OCR, Optical Character Recognition. We also ship customization options available for some of these APIs, like Lore with PhiSilica, and customization options for app content search, which we'll get into later in this presentation.
Well, after this intro detailing how Windows AI APIs give developers incredible building blocks, let's get our hands dirty. I thought it would be good to walk you through a hypothetical scenario to demonstrate how these APIs can work together and result in a truly transformative experience. So our scenario is as follows. A remote manufacturing plant is facing a production halt. Connectivity is limited, governance is strict, and a field engineer needs to diagnose and fix the issue fast. I believe that this scenario is something many of you can relate to, regardless of the industry you come from, because the challenge of working in constrained environments and needing actionable insights is universal. So let me show you how an app building process would look like. And Connor, would you mind being a field engineer for us and testing the app?
Sure thing. I think we're going to be fixing some hydraulic pumps today, so I'm glad I took fluid mechanics in college.
That's good. So great. Connor, you're dispatched to the manufacturing facility, and you're told that hydraulic pressure drop in subsystem of the plant has triggered an alarm. What would be your first instinct?
Okay, so once I'm sure the alarm is not a fire alarm, I think I would want to check the old logs and see what kind of maintenance has been done on the pump in the past.
I think that's a very good idea, and actually I do have some maintenance logs for you here.
Awesome. Okay, but Ivan, the problem here is these logs are in Spanish, and I can't read Spanish.
And that's not a problem at all. I prepared you an AI-powered app where you can use it and analyze the images.
Awesome. Okay, thank you. Let me try this out. So what I'm going to try and do is upload a photo of those maintenance logs to Ivan's app. And then I'm going to ask the app to translate the text and the image for me. Okay, let's see what happens. Awesome, okay, so I get the response in English. Now I can see what the previous logs were. And it looks like some temporary fixes were applied, which is a little concerning. It doesn't really seem like a permanent fix.
Yes, it does sound like a red flag. But before we proceed with further investigation, let me show our audience how easy it is to implement this scenario. For that, let's look at sample apps from the AI Dev Gallery, a standalone open source app for Windows developers who aim to integrate AI solutions into their apps and projects. You did switch. Thank you. So here we have a library of many samples. I will go to image samples section and choose a recognized text sample. I can upload here the same photo of the maintenance log that Connor took. Here we see the image, and overlaid is the recognized text. I can simply copy the result of this operation and use it in the next sample app. That one is in the text section, translate text sample app. We see here that we will be using Windows AI API, which means that we're using the inbox model Phisilica. That model currently supports 8 different languages. English is one of them. So I will just paste the text detected in the previous app, click translate, and we will see exactly what you saw in the Smart Maintenance app. You could, for example, also translate into French. And this is a good starting point for any developer who can take a look at the capability, then look into the source code, which is used to build this sample app, and even export a Visual Studio solution and start building on top of it.
Super exciting.
So going back to our plant, after reviewing the maintenance logs, Connor is probably eager to uncover the root cause of the issue. And before doing that, let's cover 2 concepts that will help us achieve that. Retrieval Augmented Generation, or RAG, is one of the most popular AI patterns today because it combines the reasoning power of the language model with your app's own knowledge.
Why do we need that though, Ivan? Can't we just ask the model directly?
Well, not always. The required information may not have been available to the language model at training time. RAG lets the model pull in relevant knowledge at runtime. This is especially useful when grounding responses in domain-specific knowledge base, whether it's legal, medical, or is in our case, technical domain.
Okay, I guess that makes sense, but we can't just dump everything into the model, right?
That is correct, because things would be very slow in that case. Instead, we should retrieve only the most relevant information from the app and feed that together with the user prompt to generate the response.
Okay, how do we know the right information?
I'm glad you've asked. This is where semantic search comes into action. For some search query, the traditional keyword search would get content that contains those exact words. On the other hand, semantic search looks for matching meaning and would return results, either text or image, which are conceptually related to the search query. Both of these search techniques are used in App Content Search API and are very useful when we are performing RAG. Let's see how this would look like in source code. Here we have a method which will utilize the language model to produce a response. The arguments of the methods are user query and the context extracted via app content search that we will use for retrieval augmented generation. First, we should ensure that the language model AI capability is ready on this device. If it wasn't, it would get automatically downloaded and prepared. Then we will create the model with the createAsync method. In the system prompt, we will describe the task at hand. So we're helping a field engineer root cause the issue, and we use maintenance manuals and user logs for this. We can now combine the system prompt and the retrieved content into combined context and use this to initialize the context object. It's simple as that. The remaining thing we have is to select our generation options. We have some sampling parameters which will define the coherence and diversity of the responses. And now we can generate response with our model by using these prepared objects as arguments. So the context, user query, and generation options. At the end, the generation operation, when it finishes, we will have the final text, the response of the language model at our disposal. So Connor, show our audience how this looks like in the smart maintenance app. Let's see RAG in action.
So I'm going to ask the app what might be causing the hydraulic pressure drop. Let's see what it gives us. Okay, cool. So I see the response is meaningful. It's giving me good things to look at and check. And I also see that it's citing maintenance logs that are available to the app, which is really cool. Those are the sources it used.
That's very good. I'm glad it passes your bar, considering your qualifications at college. So let's recap what we have done so far. We have helped Connor interpret physical records in a foreign language. We have extracted relevant information from a large knowledge base and generated the most likely root cause. But in our role as the smart maintenance app developer, we want to take this one step further. We want to improve it even more for our end user. For example, we know that field engineers could benefit from a more condensed, actionable insight. In this example, the language model could organize its response into 3 key fields. Recommendation would be the primary actionable insight that tells the engineer what is most likely causing the issue and suggests the next steps. The second section is warning, highlighting potential risks if the issue is ignored or not handled correctly. And evidence provides traceability and confidence in this recommendation. So one way to achieve such output is by using low-rank adaptation, or LoRa in short. This is a small adapter which would alter the model's default behavior in a beneficial way. The training on task-specific data happens in AI Toolkit in Azure environment. And once we have the adapter, it's very easy to use it. At inference time, the adapter runs in parallel with the base model, and it doesn't introduce any latency overhead. Let me show you how simple it is to add LoRa adapter in our sample app code. Because LoRa adapters are a part of experimental API, so we will need to create a new model version, experimental model, which will wrap the existing model we have created before and give it some additional experimental capabilities, including LoRa. Next, we should point to an adapter file we have here on disk. So all the files available to the app are in this directory. We will append the assets and one of them is adapter model we've prepared for this session, 331. App context. And the last thing we should do here is to load the adapter file. So LoRa adapter, experimental model, gives us access to load adapter from path. Now when we have loaded the adapter, we should also pass it during the generation loop. For that, we need to use extended language model options structure. So we append experimental. This one has additional field, LoRa adapter, where we will point the recently created object. And of course, in the end, we will not use the original model, but our extended experimental version. Experimental model to generate the response. Everything else remains the same. We have the context, including the retrieved relevant content, the original user query, and the generation options now contained inside the LoRa adapter, which was loaded. Connor, want to give this a spin?
Yeah, let's see if we can get the app to give us some of that good structured input now. So can you analyze the manuals and logs and tell me what might be causing the hydraulic pressure drop? So what we're seeing here is a JSON, basically output in JSON format, where we have fields and values. And this is super valuable because you can use this output as the input to the next stage of whatever your automated workflow is, because that workflow can now expect some kind of structured output that it knows how to use.
And the audience will recognize the structure of this JSON contains those three specific fields that we were interested in when we specified this feature.
Awesome.
So let's quickly review all three customization options for the language model available in Windows AI APIs. System prompt is the simplest one. It offers shallow customization, which relies on model's instruction fine-tuning step. It's good for quick task assignments, tone or style nudges, and simple formatting of the output. Any more complex instruction would consume the context tokens, reducing the effective input length and slowing generation down. So that would be a drawback of this method. Reg offers medium customization with dynamic content retrieval as runtime. It's good for grounding in large or up-to-date knowledge bases and gives domain adaptation without retraining. It is slower due to retrieval step, though, and similar to system prompt, it also consumes the context tokens and slows things down. Finally, LoRa offers deep customization at weight level. It's very good for embedding stable domain knowledge, performing repetitive tasks, and it boosts performance as it frees up the context tokens. As we saw in the code, these methods are not mutually exclusive, so you can combine them to achieve even better results. With this, I hope you got a glimpse into possibilities of what Windows AI APIs can offer, and maybe you got inspired how you could build transformative experiences by combining these APIs together.
Well, thanks for helping me build that app, Ivan. It's awesome to see local AI solving real-world problems. Here's a quick video of how several of our partners, both within Microsoft and externally, are deriving real business value from Windows AI APIs. These APIs enable easy, secure Windows app integrations that open up user experiences that were impossible just a year ago. Awesome. Well, now we'd like to welcome our friend Dave from Computer Center, who will tell us about how Computer Center's new app that leverages Windows AI APIs is solving a real business problem for their business.
Hey.
Take it away, Dave.
Cool. All right. So Computer Center, we operate in 70 different countries, and we operate integration centers in the UK, Europe, and the US to support the deployment of devices across those 70 million countries, and we do that for 16 million products annually. And these centers deliver high-value SLA-driven services such as device configuration, rack builds, logistics, and testing, with standout facilities like Hatfield in the UK and Alpharett in America deploying over 11,000 devices a day. So our integration centers are tightly linked to sustainability through circular services, and they offer flexible connectivity and partner integration as well. And for those of you who were at BRK346 yesterday, you might have caught a short video about our BoxLens app and how we're using that in our integration centers. Traditionally, in our integration centers, we provided device registration services in configuration areas, and we collected information such as serial number, IMEI, IED, and ingested those manually using an operative to scan barcodes, enter data manually, and then send those files in spreadsheets to different members of staff to check them and perform follow-on tasks. And each piece of data was added individually, and depending on the customer, different follow-on steps were followed, such as eSIM integration or autopilot registration. This data was then validated by a manager before being emailed to an account manager, who then managed onward transmission to customers and mobile phone carriers. This was time-consuming and slow, and as the specific steps and value-added services we perform varied from customer to customer, making sure our engineers knew what they had to do for each customer was a training and education overhead as well. So we wanted a solution which would replace the repeated use of manual scanning with an automated single-pass solution. And we wanted to automatically validate the data instead of manually validating it too. And we wanted our engineers to be able to help themselves to understand, with minimal training, what specific customer tasks they needed to perform during the process. And lastly, we wanted a platform that could integrate into other platforms as well, using middleware and API connectivities into CMDBs, eSIM registration APIs, and Microsoft Partner Center too. So we built BoxLens, and BoxLens is a Windows WinUI3 app. It's integrated with Enter ID for user authentication. We're using YOLO from Foundry Local to detect the presence of a manufacturer's device box in our build center. And then we're using OCR as part of Windows AI API to read the information on the label, recognize the text, and then use Phi Silica to extract that text and use logic to validate that the text is actually valid for things like serial number and eSIM information. And then we're integrating into things like SharePoint and CMDBs to send that information automatically to register the devices in the relevant platforms instead of doing that manually. And we've also got a chatbot that's powered by Phi Silica to help the engineer during that process. And this is really a crucial part as the tool integrates with RAG to allow us to feed customer-specific build notes stored locally on the device into the chatbot to help the engineer. So here's how it works. Firstly, the app uses the backward-facing webcam on a Surface Pro 11 to detect the presence of a manufacturer's device box. And as I said before, we use YOLO from Foundry Local. You only look once to do that. After the box is detected, we then use OCR to read the device information and then submit it into the relevant APIs. And next, we're going to ask a question of the Phi Silica chatbot, which is running locally on the MPU using Windows AI API. And we're going to ask, what are the steps for installing a SIM card? Now, at this point, the model doesn't actually know the answer to that, which is fine. And it's just basically going to tell us it doesn't know the answer to that. That's fine, actually, because it's a customer-specific answer. We don't want it to give a generic answer for all our customers. We want it to know about what we're supposed to be doing for that bill for that customer. But we wouldn't want to put all of that information into a model, because it varies from customer to customer. So we have build notes for every single customer that look like this. And that's a step-by-step guide that the engineer would follow in order to make sure that the device they register is sent to the customer in the right state. So now what we do is we're going to teach the chat assistant about that specific device build using the instruction that's in the local device in a folder on the device. And as we said, we'll use RAG to do that. We're effectively taking the power of PhiSilica running on the MPU and then extending it with specialist knowledge without having to retrain the model. And as you can see here, for a document of 5 or 6 pages long, it really takes only a couple of seconds to process that, and now it knows about the context of that customer-specific build. So let's ask the same question about installing a SIM card again. The difference now is that the chatbot knows the answer because we've given it reference that it can read and knows that for this specific customer, it has to follow these steps. And the engineer then can then go away and do that. And we could add to this, and we will add to this with things like translation as well, so that our integration centers around the world can still use the same build notes. So it gave the answer there. And if you look back there, you can see that there was actually a piece of the document that told the engineer how to unpack that SIM and install the SIM in the correct way. And we only know that, chatbot only knows that because we fed the document into that. So let's try another question. Earlier in the document, we saw a table that listed out the tasks the engineer should perform and how long that should take in total. And we can see that the answer given here is 10 minutes when we ask how much time on task does that engineer spend, which is important because we don't want the engineer spending too much time because that costs money. If we look back at the document, you can again see that there was a table in that document which RAG was able to read, and it gives the right answer, telling the engineer that they should indeed spend no more than 10 minutes on that task. So let's go ahead and register the device. And for this example, we just add it to a SharePoint list, but it could be anything that exposes an API. We could use eSIM information, and we could use autopilot information as well. We can see here, as we scroll down, in this simple example, we've registered the device. It's automatically submitted that into a database here, or SharePoint list that's stored in SharePoint. Lastly, let's just demonstrate how the chatbot is also aware of the data we scan to from the device information. So we're just going to ask a quick question about the information. So you can see here that it knows the answer as well to the information that we scanned at the start. And here we are, just to recap, the key elements of the app, the chatbot on the right, and also the data extraction as well on the left. And with that, I'm done. Please.
Thank you, Dave. And seeing how PhiSilica has found many use cases out there, then it really becomes important that it runs at good performance. In these videos, you can see head-to-head comparison for response generation time at Microsoft Build in May and what we have today. Instead of generating one token at a time, we've upgraded PhiSilica to validate a multi-token trajectory at once. This has led to 65% improvement in throughput while preserving the output quality. And some additional information, some additional improvements that we've made relate to reduction of steady-state memory usage when model is loaded. This reduction is around 37%. Reduction of peak memory usage during prompt processing by 50%. We've extended context length from around 2,000 to 4,000 tokens. And LoRa is now supported on Intel and AMD devices in addition to Qualcomm. All APIs built on PhiSilica, like rewrite, summarize, image description, and more, automatically benefit from these core improvements. But one great example is the Conversation Summary API. It had the toughest performance requirements as email threads can get quite long. Thanks to these optimizations and the LoRa adapter trained specifically for this scenario, we have cut down the time to first text from 13 seconds down to below just 5 seconds. You could see all that in action in a video that was shown earlier in Outlook Summarize feature.
Thanks, Ivan. If you work in the commercial space and you're a little concerned about the power of these new APIs, fear not, we have you covered. Users will get per app control over which generative models and APIs can be used by apps. And like many of our other features, IT admins will get group policy controls to control these APIs. So let's just quickly recap what we covered today. Windows AI APIs from Microsoft Foundry on Windows are the easiest, best validated way to get local AI into your Windows apps. There is specific value here for enterprise scenarios where maybe regulatory barriers are high or lower no internet connectivity scenarios are really interesting. And what we've showed you today is really just the tip of the iceberg. Our team is working on a lot of these APIs. We're continually improving the ones we've already shipped, and we're working on new ones that we will continue to ship and announce when we're ready. I just want to call out some calls to action for all of you. We have resources online that you can check out to get started with Windows AI APIs. We showed off a few really cool tools today that make development with these APIs much easier, like AI Dev Gallery and AI Toolkit. And please, if you have time, check out the other related sessions for Microsoft Foundry on Windows.
I'd also like to thank you all for joining us here in person and via streaming. Please share your feedback on this session by scanning the QR code and check out these additional resources on how you can get started with Windows AI APIs and the Foundry Local.
And most importantly, we want to thank all of the amazing partners that have been on this journey of Microsoft Foundry on Windows with us, and especially the folks that were able to present with us today. All right, we have a few minutes left over for Q&A. If anyone has questions, feel free to raise your hand. Even and I will also be available at the hub or off to the side right after this session. Thank you all.